हेलो गाइस, होप सो ऑल यू आर डूइंग गुड। आज हम नंबर सिस्टम्स के बारे में बात करेंगे। सो व्हाट इज नंबर सिस्टम बेसिकली। आप बचपन में भी नंबर सिस्टम पढ़ के आए हुए हो। आपने जैसे 1 से 10 काउंटिंग वगैरह पढ़ी थी, उस टाइम पर आप नंबर सिस्टम डेसिमल नंबर सिस्टम पढ़ते थे। So let us start with decimal number system first. Basically, decimal number system is all about simple counting from 0 to 9, and where 0 is included. So there are 10 numbers, not basically 9, and decimal number system have the base of 10. Base 10 means there are 10 numbers. Then we move towards binary number system that we seen a lot in computer systems. That is basically 0 and 1. Its base should be 2 because there are only two numbers. Then we move towards the octal base number system, which is basically of 8 base, because here all numbers are basically from 0 to 7, including 0 and 7 as well as. But if we include 0, so there will be total 8 numbers, not 7. And then after that we will be moving towards our final hexadecimal number system, which is included to deal with the 8085 microprocessor and becomes very important in terms of 8085 microprocessor, that is basically of base 16, where numbers are basically 0 to 9, and for the representation of 10 we use A and 11 B, and so on up to basically for the representation of 16 we use F. So that is basically 10 to, sorry, not 16, it's 15, we use F basically. So there will be 0 to 15. So hexadecimal have base of 16 because 0 and 15 both are included. So let us now basically study for the conversion trick of basically converting octal to decimal, that will be used the most in this, and binary to hexadecimal will be also be used. Sorry, we have to remember all these factors also. Okay, you have to remember basically that uh, so whenever we are converting something into a different basically number system, let's suppose we are going from binary to octal, so we have to mention with the base basically that number. So for example, if we are considering 10, so 10 is basically in which system? 10 is basically in decimal system, or basically 10 is basically in hexadecimal system, so sorry. So that is basically 10 in hexadecimal system. If we are basically, let's suppose we have 1 0, so in binary it will be 2, so 2 to the base 10, that I am saying. In basically 10 in, if we are going to consider, that was I was early considering octal to decimal. Okay, so if we are converting octal to decimal basically, so 10 will be represented octal, in terms of octal 10 will be represented as 8 to the base 10, yes, in decimal equivalent basically. So that is basically it's a decimal equivalent. So if we write 1 0 in octal, it means 8 in terms of decimal number system. So if we write 1 0 in octal, it is basically 8 in decimal number system, that I am trying to say again. Okay, 10h in hexadecimal is basically 16 in terms of decimal, yes, because F is basically 15 and 10h is basically 16. So 11h is equal to 17, 12h is equal to 18, 13h equal to 19, and 14h equal to 20. So we have to keep in our mind that these are like ways of representing the content of decimal number system, that is 0 to 9, and all that is I have mentioned. And what it means, like if we are having like 1000, so that is basically binary, and if we convert it into decimal, that is 8 to the base 10. Okay, so let us now basically study about the 2's complement. Wait a minute. Okay, so first of all, before studying 2's complement, let us study the need of 2's complement, that will be coming from the subtraction of numbers basically. But before subtraction, let us study about addition, because subtraction is basically addition of negative. Negative basically comes from the 2's complement. Okay, so let us suppose we are having two numbers basically 9 and 8, that in decimal number system. So if we add them, we are getting the output 17. And if we are having basically 9 and 6, then we will be having the output as 15. But let's suppose we want to add the basically two numbers that are given in hexadecimal number system. Let's suppose we are having F and F. So one way is basically to convert those numbers into decimal number system, because decimal addition is something like that which is flowing in our blood. Okay, and but in hexadecimal we are not so much basically familiar like how to add. So if we consider like F as 15 and another F as 15, so if we try to add them, we will be getting output as 30. But 30 should be written in basically hexadecimal system, and in hexadecimal systems I have already told you that basically what I told you in hexadecimal system, that 14h is used to represent 20. and 11H was used to represent 17. So if we moved from 17 to 20, so we were added 3 basically. So 11H added 3 is basically 14H. So you add 17, like if you want to move from 17 to 20, you have to add 3 here also na. So basically that would be leading to 14. So add 13. So according to that, that will be basically 24H. So 24H will be your output. Okay. And let's suppose you want to add F and 8. So F plus 8, basically what it means by F plus 8. F itself is basically 15 and adding 8 to it will be leading to 23. So that will be basically equal to what it like it will be basically equal to what times of H basically 23, since we are moving, so we will be basically having 17H. Okay, because we are moving from 11H is itself 17 na, and we are moving basically to 6 more times. So 11H plus 6, because from 17 23 is 6 lagging na, so we are adding 6 basically. So 11H plus 6, that will be 17H. Okay, so we have to take care of these aspects also. So one will be basically converting it to decimal and then adding basically, but we will be ignoring these tricks later on. We will be learning the direct tricks, or not formulas, that will be tricks, because they will be valid, but they will be having no kind of certain logic that could be explained to everyone in general way. That's why they are not developed as theorems, they are tricks basically. Okay, that are developed by common people and work in 99% of the cases. Okay, in terms of microprocessor. Okay, so let us move towards hexadecimal. What let's suppose we want to do F plus 1. So F plus 1 is basically what? F plus 1, F is itself 15 plus 1 itself 16, and that is basically 10H. Okay, so you have to remember these tricks. Okay, so subtraction is basically in terms of processor basically the addition of negative. So if we are doing a minus b, that is basically a plus negative of b. Yes, you have to break down it into a plus negative of b. But first of all, let us discuss with some of the examples leading to the addition of hexadecimal system, because that will be studied the most in our basically syllabus. So let us study basically uh, DEDE plus 9678. Let us do DEDE plus 9678. Wait a minute. Here I can't open the sketch pen now. That's the basic problem. Let you do the addition of DEDE plus 9678. So consider DEDE plus 9678. So how will you do the addition? First of all, think, write on your basically page, that is DEDE plus 9678. So 9 below D, 6 below E, then 7 below D, that is the D on the right side, and E on the rightmost, basically E, under that you write D. So E plus 8 is what? E is what itself? You tell me just basically. A, B, C, D, E, F. We are having up to F. What is E itself? A is 10, B is 11, C is 12, D is basically 13. So E is basically 14 and F is basically 15. So E is 14. So 14 plus 8 is basically 22. Okay, 14 plus 8 is basically 22. And we know basically 14 plus 8 is 22. What we know basically? 10H is basically what? If we are saying 10H, 10H means what? 10H means 16 or 15. F is 15, 10H is 16. Okay, so 10H is basically 16 and we are having 22. So basically we will be adding 6 to this to make it 22. So 16H will be representing 22. So 16H will be representing 22. So we will be writing 6 at the end, H, 1 will be carried over. So D plus 7. So it is basically actually D plus 7 is basically actually D plus 8 only, because 7 plus 1 is 8 and we will be countering as D. So since E was basically 14, so D will be equal to 13. You yourself consider that D will be basically equal to 13. So 13 plus 8 is basically what? So it is 21. So 21 is basically what? Earlier we were having basically 16H for 22, so that will be 15H. So 15H will be basically having again basically 5. H will be not be considered here. H is added at the end. Okay, so that will be basically 5 and 1 carried on. Okay, so again we will be having E plus 7. So E plus 7 is what about? E is itself basically 14 plus 7, that is 21 again. So that will be again 15H. So 5 again and 1 carried. And then we will be having basically D plus 10. Since D is itself basically 13 and plus 10 is 23. And 23 we try to write basically in terms here so that is 17H. 17H is basically 23. So 17556H, that will be your output. So 17556H will be your output. Okay, so that is basically hexadecimal addition. Okay, so if we consider FFH plus 95H, let us take some simpler example. So H plus H is itself what? H is itself what? You tell me. Simple, if we consider H, A, B, C, D, E, F. So H is itself what? H plus H. H plus H is itself H. So H is representing, you are going in hexadecimal system. Okay. And F plus 5 is what? F is basically itself 15. E, F, basically F 15. 15 plus basically 5 is 20. And 20 is represented as 14H. So 4, 1 carried over. And then F plus 10, F is basically 15 plus 10, 25. 25 is basically what? 25 is basically, since 20 is 14H, we have seen. So basically 25 will be basically coming out from what? 25 is 9 addition to the 10. So 19H, or 5 addition to the 14H. Okay, 19H. So 19H, 194H, that will be your output, 194H. Then your comes, if for your homework, that is 4A2C plus 5371, that comes out to be 9090. Okay, because C plus 1 is what? C plus 1 is D, and then it comes out to be 2 plus 7 9. A plus 3 is what? A plus 3 is basically B, C, D, and basically 4 plus 9 5 is 9. So because here all the numbers that are coming under the 16 base, and we have to make them under the 16 base. It means either 0 to 9 or A to F, that is your main motive. And H is basically also used. So in terms of H also, they comes out to be like 14, 15, 16H or something like that. Okay, then here comes your basically negative addition. So that is subtraction basically, and for subtraction we need to know the concept of 2's complement. That what I, so 2's complement is 1's complement, and later on basically conducting 2's complement on that basically. So what do you mean by basically 1's complement? First of all, what we will be doing, that you will be writing the 1's complement, means writing the number in terms of binary format, and then basically 2's complement means then adding 1 to it basically. So first one is number 1 ka 1's complement basically. So let's suppose you are given with a number, let's suppose you are given with a number 34 H. In hexadecimal system you are given with 34H. Okay, so you will be writing it first of all in basically bits format. Okay, so if we see 34H, that could be written in bits format by breaking 34 into two sections of equalities, that is basically 3 and 4. So what we will be doing basically, since we are considering 8085 processor, so it is a 8-bit processor, so we have to represent every number in terms of 8 bits, you have to remember. So 8 bits. Okay, so 34H can be written as, 3 can be written as 1100, sorry 0011, because we read from left side, and 4 can be written as 0100. So that is your binary. Now we will be basically converting it into 1's complement, that is 1100 1011. Then basically we will be adding 1 to it. So 1 1 addition is 0, carry 1, 1 1 addition again 0, carry 1, 0 1 1 1, and then basically 0 0 1 1. So this comes out to be, that is 1100 is coming out to be basically what? That is 2 to the power basically 3 plus 2 to the power 2, that is 12, and 12 is basically C, and then right side also CCH will be your output. Okay, so that is hexadecimal system. So now if we do 98H plus CCH, let us do 98H plus CCH, then because I need to explain you some concept. So that is, if we do 98H plus CCH, because negative addition we have to do now, CCH is basically negative, that is minus B. So H plus H is H. 8 plus C is what? C is itself basically equal to 12. A is basically 10 now. B is basically 11. C is itself 12. Since 12 plus A is equal to 20, and 20 is basically represented as 14H. So basically 4 and H 14 1 carried over. So 10 plus C, so that is basically C is 12, so 10, that is 22, and 22 is represented as 16H. So that is 164H will be your answer, but you have to basically neglect 1. Yes, because earlier if you are having the number in terms of 2, that is 98H or 34H, you can't write here in terms of 164. Okay, you have to write in basically 2 sets or 2 numbers only, means the number of places that are, it means that because this is a 8-bit processor, so it can't process basically 12 bits. Remember, since it is a 8-bit processor, so if we will be writing it as 164, and then we have to write one separate, 6 separate, 4 separate. But since it is a 8-bit processor, so we have to represent it in terms of basically 8 bits only, and one number, that is 98, one means 9 and another is 8, will be taking a 4 bits. So total basically 8 bits are consumed by two places. Okay, that I am trying to say. So this topic is also over, and from next lecture we will be moving towards very important and basically easy topics, but that will be playing a lot of role basically in your exam syllabus and basically understanding of questions that is basically related to architecture, because architecture questions come in your every exam. If you prepare for gate or any other exam, they always come. But in the sense basically in terms of syllabus, the question putting that in the exam is also done many times, that is I'm saying. And after that we will be moving towards other topics. So first we will be moving towards the architecture of 8085, that I have to explain you with the help of some good diagram also that I will be using for that purpose. Okay, so don't worry regarding that. I will be trying to explain with my best efforts to you. This diagram I am talking about, I will be bringing the printed version of this one. Okay, so don't forget to like the video and share also. Bye bye guys.